for a linear polynomial x plus b, the graph y is equal to x plus b is a straight line. You all know that. And which intersect the x-axis at exactly one point, namely minus b by a 0. Minus b by a 0. And here the x-coordinate is minus b by a, and that is the 0 of the polynomial. Okay, that's the idea. So now I will add two more things to this. Okay, p of x is equal to x itself. P of x is equal to x. Can you find the 0 of this polynomial?
0, 0.
0, 0 is the intersecting one. Very good. My question is, what's the 0 of this polynomial? Sorry, 0 of this polynomial.
0.
0. Yes, 0 is the answer. 0 is the answer. Okay. So here p of x is equal to x. For p of x is equal to x, here a is equal to 1 and b is equal to 0, right? This is of the form 1 into x plus 0. Okay. So here minus b by a, the 0 will be, the 0 of this polynomial will be minus b by a, that is 0 by 1. What is 0 by 1? That is 0. If you draw the coordinate axis and if you put 2 points, for every x value, the y value will be the same. For every y value, the equation will be like this: y is equal to x. Okay. If you give x is equal to 1, the y will be again 1. Okay. So it will pass through 0, 0, 1, 1, 2, 2, 3, 3, and minus 1, etc. So the graph will pass through 0, 0. The graph will pass through 0, 0. So the 0, 0 is the intersecting point of the y is equal to x, the line, and the x-axis. So take the coordinate of x coordinate of the intersecting point. X coordinate is 0, right? So the 0 of this polynomial y is equal to x is 0 itself. Okay. So this is what the content we studied today. So for second degree polynomials or quadratic polynomials, we will discuss in the next class the geometric idea of zeros of a second degree polynomial. In 9th standard, you have studied polynomials of degree 0. Degree 0. So for example, it will be of the form p of x is equal to, if degree is equal to 0, that means it will be of the form a into x raised to 0. It will be in the form x raised to 0 is 1. X raised to 0 is 1. So it will be of the form p of x is equal to a constant number. If degree of a polynomial is 0, it will be of the form p of x is equal to a. Okay. So for example, p of x is equal to simply 4. Okay. For another example, p of x is equal to simply 0. So how will be the geometric idea of the zeros of these polynomials? And in 9th standard, you have studied that this kind of polynomials, degree 0 and the value is not 0. Suppose value is not 0, then we can say, suppose a is not equal to 0, then we can say the polynomial as a constant polynomial. A constant polynomial. If if p of x is equal to 0, we can say it's a zero polynomial. So what will be the geometric idea of the zeros of this polynomial? Okay. So I'll suppose these two examples we'll do here. Suppose p of x is equal to 4. Suppose p of x is equal to 4. So I draw the coordinate axis. So p of x is equal to 4. We want to draw the graph of p of x is equal to 4. That is y is equal to 4. So y is equal to 4. How can we draw this graph? Y is equal to 4. If you take the table like this, so x and y. So if you choose x is equal to 1, the y is 4. There's no x in the equation. Okay. If you take x is equal to 2, the y is 4. Because the equation is y is equal to 4, it is independent of the value of x. Okay. So if you choose any x value, the y will be 4. So the graph will goes like this. For every x values, the coordinate, the y coordinate will be 1, 2, 3, 4. So the graph will be like this. I shall draw with a different color. So the graph will be like this. The graph of y is equal to 4 goes like this. Okay, and in 9th standard textbook, you have seen that for a constant polynomial, there is no zero. You check your 9th standard textbook, you can see that for a constant polynomial, there is no zero. Okay, because why? This graph doesn't intersect the x-axis. Okay, this graph doesn't intersect x-axis because this line is parallel to x-axis. Parallel lines never intersect anywhere, right? So for a constant polynomial, there is no zero, and that line doesn't intersect x-axis. Okay. Now take a p of x is equal to 0. P of x is equal to 0. This case. Okay. P of x is equal to 0. So here, suppose we draw the table like this. For different values of x, suppose I take x is equal to 1. What will be the y value? Y value will be 0, right?
0.
Yes. Suppose I take x is equal to 100. What will be the y value?
0.
0.
0.
Yes. So if for every x values, the corresponding y value will be 0. So 2 points, if you take 2.10 and 100, 0, if you join these 2 points, the graph will be on the x-axis. Okay. So intersecting points means the coordinates, x coordinates of all the intersecting points means every points on the x-axis are zeros. It intersects at everywhere, right, on the x-axis. So that means all the real numbers are zeros of this polynomial. This polynomial is called zero-polynomial. Zero-polynomial. So for zero-polynomial, there are uncountable number of zeros. So you can say in 9th standard textbook, for a zero-polynomial, there are infinite numbers of zeros. The geometric idea is that if you draw the p of x is equal to 0, the zero-polynomial, the graph will be same as the x-axis. So all the points on the x-axis are intersecting points of the graph p of x is equal to 0 and x-axis. Okay, so all the x coordinate means all the real numbers. So on the number line we can mark every real number, right? So all the real numbers are possible zeros of y is equal to 0, the zero-polynomial. So the polynomials of the chapter we can divide into 3 parts. First one, geometric meaning of zeros of a polynomial, the relationship between zeros and the coefficients of a polynomial, the division algorithm of a polynomial. We started the first part, that is geometric meaning of zeros of a polynomial. We didn't discuss different degree polynomials, but only linear polynomial and 0 degree polynomial. So next lesson we will discuss second degree polynomial, that's quadratic polynomial and cubic polynomial. So we conclude this idea like this: and linear polynomial x, p of x is equal to x plus b, a not equal to 0. The graph y is equal to x plus b is a straight line which intersects x-axis at exactly 1 point, namely minus b by a 0. And minus b by a is the x coordinate of the intersecting point, and that is the 0 of the linear polynomial.